Good evening, everyone. Can you all spot the battery that's on the picture behind me? It's quite obvious if you know the answer. No, it's not the water. It's actually the mudflat, the sediment, that is one big natural battery. This might seem like an ordinary mudflat to you, but what it is it's buzzing with electricity. And this is all due to what I find are the coolest bacteria around, electrical cable bacteria. If only our eyes were able to see more than just what we see now, if they were able to see electrical currents, we would see a true spectacle going on behind my back. Thousands of little sparks running through the upper centimeters of the sediment, and each of these sparks caused by one of these electric cable bacteriums. And here lies once again a big chance for us to learn from nature, because we have calculated that these guys can conduct electricity with the highest efficiency of any biological structure. Quite intriguing, no? So let's meet them. This is an electric cable bacterium. So we might need a microscope to actually look at these guys, but please don't consider them as being tiny. They're really humongous in the microbial world. They might be thin, they're like 1/10 of a human hair, but they're very, very long. They can stretch up to centimeters in size. They do this by stacking tens of thousands of cells, one after another, and this will form this very, very long string that ends up in the sediment. And each of these strings has a very special characteristic. Each of these strings will produce this very small current in the sediment. But why? Why would a bacterium grow into centimeters of size and produce a current in the seafloor? I think this is best explained if we take it back to our own world. So let's imagine a world where an apocalyptical event took place. Some things have remained the same, some things have changed. Ghent and Bruges are still 35 kilometers apart. But in Ghent, we find a lot of food, but our air is completely devoid of any oxygen. In Bruges, however, 35 kilometers to the west, we have a lot of oxygen in the air, but there is absolutely no food available for the people there. A way to survive in such a world would be to form a very, very long string of humans, tens of thousands of humans, stacked one on top of another. And this very long string of humans will have to cooperate to exist in this new world. The people of Ghent will do one essential part of the metabolism. They will do the eating part. The people of Bruges will do the other essential part of the metabolism, the breathing part. And this is actually exactly the scale and the kind of environment that cable bacteria deal with in the sediment. These guys, the bottom cells, will do the eating part. They will harvest little energy packages from their surroundings. These energy packages will be in the form of electrons. And they will be sent up to the only cells that have oxygen, and that are the very, very top cells. This will create a flow of these electrons, and this will produce the small current that we have seen in the seafloor. So whenever I talk about these bacteria and electricity, the first question that pops into the mind of many, many people is, can we actually use this power? Can we use electrical cable bacteria to light up our houses or just to light a bulb? I can give a very short answer to this, and that is yes. Yes, we would be able to harvest energy from this electric cable bacteria. But truth to be told, we would need quite a lot of mud to do so. So let's stay more reasonable. Let's say I only want to charge my phone based on this electrical mud. Then I would need an area of a typical student room here in Ghent. I would need 20 square meters of mud to charge my phone. So no, I'm not giving the next solution to the next Belgian blackout. But still, it's amazing. It's this natural battery, the best natural battery around, caused by these cable bacteria. And we have a lot of these natural batteries around the whole world. Please bear in mind that this research is very recent. Cable bacteria were only discovered 5 years ago. And then only 3 years ago, our team, composed of scientists of the NIOZ and the VUB in Brussels, joined in. And already in this short period of time, and with this few people, we have been able to prove that these cable bacteria live from the very north of Greenland to the very warm mangroves of Australia. And that's not the end of it. So they're very long, they make the sediment function like a battery, but they are also the most conductive structures in any biological organism as we know it, if our calculations are correct. But like I said, this research is very recent, so we still don't know how they do it. So perhaps a colleague of mine will tell you all about it in a few years. So what I want you to take home from this is the next time that you walk over the seafloor, don't consider it as something that is dull. It's buzzing with electricity just underneath your feet. All of this caused by this very long and very intriguing bacterium, this electric cable bacterium. And who knows, perhaps sometimes in a far future, if we would zoom in on our own coastline, we will see power sockets coming out of them. With this, thank you.